everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be doing one of our algebra topics of factoring, but more specifically when our a value does not equal 1. So sometimes it's a little bit more straightforward when our a value is 1 to find what our solutions are going to be. However, when our a value is not 1, whether it's a negative or it's a positive greater than 1, there's an extra step that we have to take. So we want to be able to know those steps to accurately be able to complete these problems. So there's some important information we have to know when we're completing this. First of all, what are we doing and why? So we are taking our quadratic equation, setting it equal to 0, and then solving to be able to find our x-intercepts or our zeros of the equation. So once we find our solutions, that means when we plug those numbers in, our whole quadratic equals 0. So it's where our answers are crossing the x-axis or x-intercept. Another important thing is to know what even is a quadratic. A quadratic is in the form of ax squared plus bx plus c. It will be equal to 0 when we're trying to factor it to solve for our solutions. Our a is our first coefficient in front of our x squared, our b is in front of the x, and our c is our constant. So those are very important to know because we're going to be using the terms a, b, and c often. You're going to be like, what is a, what is b, what is c? So our rules to complete this is we're going to multiply our a value times our c value. Once we do that, we have to think what two factors will multiply to our a times our c and add to our b value. Once we find those two factors, we're going to plug them into the middle with our x's attached. So now it's going to be something like 2x squared plus 3x plus 4x plus 5, for example. Obviously, that's not accurate, but that would be, for example. Once we find our two factors, we throw them into the middle of the equation. Instead of our b value, now we split it up to two different b values that add up to that b value. And then we're going to factor by grouping. So we're going to look at our first two numbers, group them, factor by grouping, take our second two, and we want to make sure that those factored numbers are in our parentheses are the same. If they're not the same, we can't continue with that problem. We did something wrong. We either need to take out another number or we chose the wrong factors. It didn't make sense, didn't work. So let's take a look at an example problem because a lot of this is just words that we're throwing out there and see what we would have to do. So now we have the problem of 8k squared plus 29k minus 12. And my first step is to multiply my a value times my c value. So I'm going to do 8 times negative 12. When I put that in my calculator, I get a negative 96. So I'm now trying to find two numbers that multiply to negative 96 and add to 29. So I can put in my calculator, divide by 2. That's not going to work. Divide by 3. And I get 32 and negative 3, which is going to work. Negative 3 times 32 gives me negative 96. 32 plus a negative 3 gives me a 29. So that's what I wanted. So instead of like normally when we have a equals 1, we just say, oh, it's k plus 32, k minus 3. We can't do that because we have a coefficient that's greater than 1 for our k squared. So we're going to plug it in the middle. So I'm going to have 8k squared. Now I have to think, which one would better off give me a greatest common factor, the GCF out of? So I want to look and see. I have 8 and I have 32k or I have negative 3k. Which one's easiest to find a GCF of? Of course, we could do it in any order, but I like to do what makes life a little bit easier. So I'm going to use the 32k. So plus 32k minus 3k minus 12. Now our last step of this portion was to factor out a GCF. So I'm going to look at these two. What can I take out of these two? My GCF is an 8 and a k. When I take that out, I'm left with a k. 32 divided by 8 gives me 4, so plus 4, because the k's will cancel out with each other. Now in the second part of this, I want to make sure that I'm getting a k plus 4 in the parentheses. If we do not have the same thing in the parentheses, we are not successfully factoring. So I'm going to look, what can I divide out to both of these? I can divide a 3. But if I take a 3 out, I'm going to have a negative k minus a 4. That is not the same as k plus 4, so I am going to take out a negative 3. So I'm left with a k plus 4. Both of these must be the same, so what can I take out of this to make them both be k plus 4? A negative 3 works. Now, we are going to take the 8k minus 3 and put that as one of our factor equations. And then we have a k plus 4. It's almost like we're taking another GCF. They both have k plus 4 in common, so we're taking that out, and that's going to be on the outside as k plus 4. Then if I wanted to find my zeros, I wanted to find my true solutions, because it asks us to factor it, but a lot of the times they're asking for the solutions as well. I would set this equal to 0, and I would get ak minus 3 equals 0 to find my zeros, and that gives me k equals 3/8. And if I set this equal to 0, I subtract 4 over, I get k equals -4. So we just showed you everything. We showed you factoring it when a is not equal to 1. We showed you the factored form, which technically is set equal to 0. And then I found my zeros by setting each of these binomials equal to 0 to find my solution. So at both of these, in quotes x values, because I know it's a k, this is where they cross the x-axis. Let's take a look at one more problem to make sure we're fully understanding what we should be doing here. So now I have 10n squared minus 33n plus 20. Now I'm going to do the same process. I'm going to do 10 times 20, because that's my a and my c, equals 200. So I'm trying to find two factors that multiply to 200 and add to -33. So if I divide by, let's say, 4, that's not going to work. 5, that's not going to work. I have 8 and 25. Obviously, 8 times 25 is 200, but 8 plus 25 is a positive 33. I want a negative 33. So we can think about our negatives, though. A negative times a negative does give me that positive 200. So I can think of negative 8 and negative 25. Because I multiply them, I get 200. I add them, I get negative 33. So now I'm going to continue, and I'm going to plug it into the middle like I did prior. So I'm going to have 10n squared. Now if I look, though, negative 8 and negative 25, they both will have a GCF, but it's not going to be an even one like we did before where it gave me x plus 4. So I could put either one. I'm going to decide I'm going to do the minus 8. And once again, it doesn't matter which way we do it. We'll still get the same answer. Minus 25n plus 20. Now I look at the first two, and I'm going to try to find a GCF. So I'm going to take out a 2 and then an n. When I divide this by 2n, I get 5n. When I divide this by 2n, I get a minus 4. If I refoiled this in, I would get 10n squared minus 8n, so you can check your work that way. Now on this inside, I want to get a 5n minus 4. Well, these both have 5 in common, but if I do plus 5, this is going to give me a negative 5n plus 4, which is not what we want. We want 5n minus 4. So I'm going to take out a negative 5, and that leaves me with 5n, and that leaves me with minus 4, which is exactly what I wanted here. So now you take the outside number, the 2n, attach it with the minus 5, and then we take one of the 5n minus 4, because it's like we're factoring out that GCF. The GCF, they both have in common the 5n minus 4. So I took it out, and I'm left with 2n minus 5. And obviously this equals 0, because when I set it equal to 0, I can find my zeros, where they cross the x-axis. So I set 2n minus 5 equal to 0, solve that two-step equation, and I get n equals 5 over 2. I set this equal to 0, and I get n equals 4/5. So sometimes your teacher might ask you just to factor it, give me the factored form, but then they also might ask you to give me the solutions. My solutions are my zeros, and those would be my answers. And if I wanted to check if I was correct, I could plug in 5/2 for my n, and that's what my answer should be. It should give me 0. So once I plug in 5/2 for n, or 4/5 for n, I would get an answer as 0 for the whole entire quadratic, and then I know I'm doing it correctly. So I hope this was helpful to see how we would factor an equation when our a value does not equal 1.